Last episode, our loss curve slid from 0.69 down to 0.18, and we high-fived because training clearly worked. But a falling loss only tells you the model got better on average. It never tells you where it still trips. That's the whole catch with a single number. It hides the failures. So this episode, we run the fine-tuned classifier across all 9,000 held-out reviews, collect every prediction, and lay them out in the one chart that shows you the mistakes by name. It's called a confusion matrix, and once you can read it, you will never trust a bare accuracy number again. Picture a movie review site. Half the reviews are glowing, half are scathing, and we want a model that can tell them apart automatically. That's binary sentiment classification. 2 buckets, positive and negative. We already fine-tuned the model last time. Now we're putting it through its final exam on reviews it has never seen. Here's the thing every beginner gets wrong. Accuracy alone is a liar. A model can be 98% accurate and still be useless if the 2% it misses are all the same kind of mistake. 98% right doesn't tell you whether the wrong answers were false alarms or things it slept through. We need to split the errors apart. Every single prediction lands in exactly one of 4 boxes. True negative, it was negative, we called it negative. Correct. True positive, it was positive, we called it positive. Correct. False positive, it was actually negative, but we shouted positive, a false alarm. False negative, it was actually positive, but we called it negative, a miss. 2 ways to be right, 2 ways to be wrong. Stack those 4 boxes into a 2x2 grid, and you've built a confusion matrix. Rows are the truth, columns are the guess. The 2 boxes on the main diagonal are the wins. The 2 off-diagonal boxes are the losses. The shape of the grid tells you the model's whole personality at a glance. Now color it. Paint the diagonal green and the off-diagonal red, and the chart reads itself. A healthy model glows green down the middle with 2 faint red corners. If one of those red corners ever lights up bright, you found your model's blind spot without reading a single review by hand. To actually fill those 4 boxes, we need predictions on data the model never trained on. That's why we held out a test split back in the datasets episode. We run inference across the whole test set, line up each prediction against its true label, and tally which of the 4 boxes it falls into. 9,000 reviews, 9,000 tally marks. And the tool that does the tallying is one function from scikit-learn, confusion matrix. Feed it the true labels and the predicted labels, and it hands back the 4 counts already arranged in the grid. No loops, no bookkeeping. One call turns 9,000 predictions into a 4-number summary you can actually read. Okay, into the editor. One file, zo6classifier.py, 3 pages. Page 1 loads the dataset and tokenizes it. Page 2 fine-tunes with the trainer, exactly like last episode. Page 3 runs prediction and builds the confusion matrix. Everything we've learned across the last 5 episodes lands in this one script. Page 1 is all set up we've seen before. We load the IMDb dataset from the hub, grab the tokenizer for Distilbert base uncased, and write a tiny tokenize function that pads and truncates each review. We map that over both splits, then shuffle and slice down to a few thousand examples each, so the whole thing fine-tunes in minutes instead of hours. A data collator with padding handles dynamic padding per batch. Page 2 is the fine-tune. We load auto model for sequence classification with 2 labels, set our training arguments, 3 epochs, batch size 16, evaluation every epoch, and hand the model the datasets and the collator to the trainer. One call to trainer.train, and the loss falls just like the curve we watched last episode. This part is muscle memory now. Page 3 is the new material. We call trainer.predict on the held out test set, which returns raw logits for every review. We take the argmax over the logit pairs to turn each one into a hard 0 or 1 prediction and pull the true label straight off the dataset. Then the one line that matters, confusion matrix, labels, spreads from scikit-learn unpacks into our 4 counts, TN, FP, FN, TP, and we print them next to the saved predictions line so the terminal and the chart agree. And look at what those 4 numbers say: 4380 true negatives and 4405 true positives sitting fat on the diagonal. The model nails the easy calls. Off the diagonal, 120 false positives and 95 false negatives, slightly more false alarms than misses, but both corners stay faint. That's a healthy, balanced classifier. The matrix has the raw counts now. Next episode, we turn them into the metrics everyone actually reports: accuracy, precision, recall, and F1.